Assalamu alaikum, dear students. My name is Alia Sadiqa, and I am going to discuss with you today's test, which is test number 2. And we'll be discussing the test, which was comprising of reaction kinetics, along with the English and logical reasoning portion. I hope that this test is going to be really beneficial for all of you. And this test was a free experience for all of you to experience what kind of questions you get from the reaction kinetics chapter. Importantly, how English questions come in the MDCAT paper, and most importantly, how the logical reasoning portion is being judged in the MDCAT test this time. So let's start with the test discussion. We have with us the question number 1, which was that what does the Arrhenius equation explain? Well, on the screen, you can easily see that the Arrhenius equation is K is equals to AE minus EA divided by RT. We discussed this equation particularly when we are talking about temperature. Temperature in terms of factors affecting reaction rates. At that time, we talked about how temperature is being affected by reaction rates, and at that particular point, we talked about the Arrhenius equation. Well, in this equation, the important part is the temperature. So what does the Arrhenius equation explain? Well, when you're solving MCQs all from the online, when you're doing this practice, bring it into your practice that first of all, cut out those options which are not necessarily the part of that particular MCQ, and they are extra. For example, in this particular equation, you're watching that there's no contextual talk about the pressure or volume. So we will simply omit the A and C option, and we'll go on with the B and D option. If I talk about the B option, it is the concentration of substance. Well, as I told you in the start, that Arrhenius equation deals with temperature and it doesn't deals with the concentration of substance. So B is the incorrect and we have D as the correct answer. Next we have with us is, okay, so by the time it's loading, we'll go on with our next MCQ, which is that half-life for first order reaction is. Well, we have some reaction orders, and reaction orders are zero order reaction, first order, second order, third order, and fractional and pseudo first order reactions. If we talk particularly about the first order reaction, we know this thing for a fact that first order reactions do not depend on the initial concentrations. Like we see in the second order reactions, with increase in the concentration of reactant, we see that there's an increase in the second order reaction. Because of that, we see that if the reaction is this is squared, then its concentration is also going to be doubled. Its concentration is also going to be doubled. But in case of first order reaction, things are quite different. It is independent of the initial concentration. So simply we'll go on with the equation of half-life. What is the equation of half-life? That is T half is equals to 0.693 divided by K. Over here, K is the rate constant. So if we look into the options that have been given to us in this test, if you see the option 1, that's the formula which is incorrect. Option B seems to be the correct one. Option C and D are also incorrect. D is also having the incorrect formula. So from this, we deduce that the B option, because the rate reaction is independent of the initial concentration. So first order reaction, we say that it is going to have the B option. Next, we have with us okay. So next MCQ that we are having, give me a second. By the time it's loading, let's see the next MCQ, which is that which of the following is the factor which actually helps us in is factor affecting the rate of reaction. Well, anybody who wants to reply it, So we have option number 1 as amount of substrate. We have option number 2, which is we have option number 2, which is the catalyst. We have option number 3, which is the temperature. And we have option number 4, which is all of these. Well, if I talk about which of the following is factor affecting rate of reaction, I would like to go into the topic of rate of reaction. When we talk about rate of reaction, we know this thing that rate of reaction means the time in which a reaction is completed. And we, in our books, we have studied it very clearly that there were 4 factors which were affecting the rate of reactions. Well, the number 1 factor was the amount of reaction. Number 2 factor was catalyst. Number 3 was the temperature. So if we talk about the catalyst stuff, we see that, yes, we have got the yes. So we see in the amount of substrate, first of all, with the increase in amount of substrate, as we have more substrate, the rate of reaction also increases. So it is having a direct relation with rate. Next we have is the catalyst. Catalyst, what is a catalyst? Catalyst is what speeds up the reaction. It is also directly related to the rate of the reaction because it's speeding up the reaction because of decreasing the activation energy. As the rate increases, kinetic energy of the molecules increases and the temperature eventually also increases. So from this, we can say that the correct option of this MCQ is D. Next we have is before a collision, molecules dash. We have some options with us. We have the option number 1, which is get faster. Well, if we talk about collisions, there are 2 situations, before collision and then we have an after collision situation. And between it is the transition state. So before collisions, we know that molecules are moving very fast. They are moving very fast. A point comes at which we see one thing, that when molecules have to react with each other, at that particular point, molecules react, they start to come closer. And when they come closer, their speed decreases. Their speed eventually decreases and they slow down because they have to react. So over here, get faster is incorrect. None of these is not. Stops is actually the reaction is disintegrated, which is not actually possible. And we have the last option, which is slow down. So slow down is the correct option of this particular MCQ. Next we have is for a chemical reaction, particles must collide with. Well, whenever a reaction, particularly a chemical reaction is going on, we have some important things to discuss. For a collision, when a collision we are seeing in this MCQ that particles must collide with, it means that there's some kind of collision. When collisions are going on and they are having proper orientation and structure, orientation along with a proper structure, at that point we say that they are having effective collisions. And when they are having effective collisions, these are the most important things to happen. So in this particular MCQ, if we look into the options, we say that for a chemical reaction, particles must collide with. Proper energy, yes. In a homogeneous mixture, yes. Like molecules have a better collision rate. Proper orientation, yes. So all of these is going to be the correct answer. Moving forward, we have it that Arrhenius constant A depends upon. Well, we just discussed about the Arrhenius equation and now talking about the Arrhenius constant A. With Arrhenius constant A, we see this thing that in this particular equation of Arrhenius, this particular thing is seen that it deals with temperature. Arrhenius equation is dealing with temperature. And temperature, in temperature particular factor, we see that collisions, especially effective collisions, were happening. So in this particular option, we will correct not universal gas constant. It's incorrect. AE minus RT. R was actually the universal gas constant, which is incorrect. Activation energy is also incorrect. So we have the correct option, which is collision frequency of reacting substance. And what is collision frequency? Number of collisions done in a particular time is known as the collision frequency. So this is the correct option. Next we have with us is that how does catalyst increase the rate of reaction? Well, catalysts, their behavior is quite similar to that of an enzyme. But enzyme is biological, catalyst is chemistry. Enzyme we study in bio, in catalyst is the enzyme of the chemical reactions of chemistry. So catalyst has this property of actually not being consumed in that particular reaction, not being consumed in the reaction, rather it lowers the activation energy, and because of that it takes the control of overall reaction and it fastens the reaction rate. So over here we have the correct option, which is D. Moving forward, we have our MCQ number 7, and I hope that this particular practice of online MCQs will literally give you a lot of benefit in coming MDCAT exams. In the rate equation, we see that it is being asked that the sum of terms A and B is called. Well, if we know the definition of order of reaction, because in all the MCQs answers, it's asked the order of reaction. So if we see the order of reaction, we know that order of reaction deals with the sum of the particular powers, which are the rate powers. So we say that A plus B is actually showing us the overall rate of reaction. Overall rate of reaction. So if we see the option B, or order of reaction with respect to A, if they would have asked us in terms of A, then option B would be correct, but it's not asked. And similar goes for D. If B was asked, then we would go with the option D. So this is the correct option. Next we have with us is that which of the following is not true about rate of reaction? Well, rate of reaction, and as I told you, that it is the amount of time in a particular reaction where the reaction is showing us different ups and downs, and we see these things in the reaction. So over here, the answer will be, let's see the options first. We have that which of the following is not true about rate of reaction? Well, when rate of reaction is happening, we see changes in concentration, change in concentration, we see a change in temperature, we see a change in intermolecular forces, we see a change in different kinds of reactant concentrations, particularly then we see a change in time, that's most important, through which we find the rate. We see also, we see these things. So if we see this particular MCQ, if I talk about option A, that it depends on reactant concentration. Yes, it is correct. We see a constant quantity, it's something questionable. We have changes with time, yes. Units are mole per dmq per second, yes, it is correct. So the incorrect, most importantly, while solving an MCQ in the paper, just see if not is written or not. So in this particular MCQ, not is written. So we have B option as the correct one, which is the constant quantity. Because if it's gonna be a constant quantity, then all these particular things are gonna be called as incorrect, which is not even possible. So B is incorrect. Next we have with us is that an effective collision between the molecules is primarily responsible for. Well, whenever effective collisions are going on in a particular molecule, a stage reaches that, as I told you, before the collision, then there's a transition state, and then there's this after the reaction. In this particular transition state, we see that a temporary structure is being made, which is quite unstable, but it is being made. And that instability, that unstable structure is actually known as the activated complex or transition state. Activated complex or transition state or transition state. So when this is happening, we see that the effective collision between molecules is primarily responsible for product formation, no. Reactant activation, no. Intermediate formation, that's not the exact word to say, because according to textbook it is the activated complex formation, because it is happening in between the two effective collisions this state comes. So this is the first 10 MCQs. Now let's move on to the next 10, which are going to be a bit um, tough, but are going to be easier after this explanation. Which substance increases the rate of reaction but recovers at the end? Well, as I told you, that reactant product are not, as I told you, that particular way of doing the MCQ. A and B options are incorrect, just take them out. Now, what are the relevant options? We have the catalyst and we have the reagent as the perfectly relevant options. So, reagent is something which is being used up in the reaction. It is used up in reaction, and catalyst is something which is actually used to speed up the reaction and not is being used up in the reaction. So the correct answer is going to be the catalyst. Next one we have with us is the specific rate constant of a chemical reaction. Is rate of reaction when concentration of reactant is. And if somebody knows the definition of specific rate constant, then we can easily understand this particular MCQ. What is a specific rate constant? Specific rate constant is that rate at which the concentration becomes equal, the rate of reaction becomes equal to unity. So in this particular MCQ, we see that the rate of reaction when concentration of reactants is unity is the C option. So we will correct the C option. Less than unity, not possible for specific rate constant. But if it wouldn't be the specific one, we would use the A and B options. But over here, the MCQ's nature is different. Moving on to the next one, we have with us, it is a tricky MCQ, and let's see how we will do it. Well, I think that most of you would have made it correct, and let's see what would be the answer. We have with us that the unit of rate constant of second order reaction is what? Well, we all know that what is the actual form of a reaction rate. What is that actual particular form? It is mole per dm cube per second. This is the particular way. So it is actually a second order reaction. If it is the second order reaction, then how are we going to write the reactions equation? Rate is equals to K, which is the constant, and we have A square, which is showing us the second order reaction. Now we have to actually find the unit of rate constant, which is K. So when we have to find K, we will use it as rate, which is being divided by A square. So if we keep it like this, we will see that rate is equals to, if we keep it like this, then we will see this particular thing, that as I told you, that the unit is mole per dm cube per second. So according to this particular way of writing, we will see that it's going to be mole per dm cube plus 3, because from this way it's going to move up. Mole per dm cube per second whole square. So it's going to be 6. It was minus 6 before, it's going to be plus, and now it's going to be plus per second. So we have this particular form after simplifying it. We had the rate equation also. So rate will be equal to mole per dm cube per second, and then we will solve it all and we will get the answer, which will be mole per mole dm cube, which is per second. Moving forward, we have our next MCQ, which is the second order reaction becomes first order when? Well, this is a tricky one. The second order reaction, as I told you right now, what is a second order reaction? This is the particular way of writing a second order reaction. So, how it becomes first order reaction? How it becomes first order reaction? Well, when one of the reactants is limiting? No, I don't think so. When the case of limiting comes, we are usually going on with the pseudo reactions. And we have read only one type of pseudo reaction, which is pseudo first order reaction. If the concentration of reactant is some kind of constant, we see that its concentration can actually be included in the rate constant. And when it is included in the rate constant, we see that at that particular point, it is going to be, it is assumed to be a pseudo reaction. Now, when we see that one of the reactants is in such excess, it is actually showing us that it is a second order reaction. Because in second order reaction, when it moves to the first order reaction, one of the reactants becomes large and the other reaction becomes constant. If we take over here B, and it is constant. It is constant. Now it is showing us a situation, and we take the concentration of A as 1, and we take the concentration of B as constant, or we take the concentration equal to 1. At this particular point, if we take the sum of A and B, which is 1 plus 1 is equals to 2. So from this condition that I told you, we can say that the second order reaction has become first order. Next we have with us is the half-life time for a first order reaction decomposition of a substance dissolved in CCl4 is 2.5 hours at 30 degrees C. The amount of substance left after 10 hours if the initial weight of substance is 160 gram. Well, first of all, if we go into the formula, and the first part is the 2.5 hours at 30 degrees C. So we have this formula, which is very simple, that number of half-life is equals to, number of half-life is equals to the total time divided by time of only one half-life period. So how much time do we have half-life period? So if we see this particular equation, this MCQ, we have that the amount of substance left after 10 hours. It means that in this particular reaction, we have the maximum time as 10, which will be divided by 2.5 hours. What answer do we get after dividing 10 divided by 2.5? Well, if you just remove the point from it, you will simplify it and get answer as 4 hours. Now that we know that what is n, actually from number of half-life time we got n. Now from n we will deduce the actual the question was that the amount of substance, we will deduce that. So for that, what we will do, we will put it into the formula, which was 1 over 2 into n, which is multiplied by initial quantity. So initial quantity. So the value of 1 over 2 to the power of n is actually 4. So this is what 4. And we also have that the initial weight was 160 gram. So if I just rub some of it from this side. Yes. So we have 1 divided by 2 to the power 4, which is 2 into 2 into 2, which is 8 into 2 is 16. 1 over 16 multiplied by 160 multiplied by 16 ones are and 16 tens are. It is equals to 10 grams. So the correct answer is 10 grams. Next we have with us is the hydrolysis of ethyl acetate into acetic acid and ethanol in presence of mineral acid is. Well, first of all, the thing is this, that in such kind of reaction questions, one thing is that you have to memorize your book a lot, because this is a memory based question. Number two thing is the concept. When you see the hydrolysis, number one thing, hydrolysis, and then of ethyl acetate, we see that in this particular case, there is excess of product. When there is excess of something, as we discussed in the previous MCQ, there is a pseudo reaction going on. And when pseudo reaction is going on, it is what we get in our book is the pseudo first order reaction. Not the first order reaction, because first order reaction does not depend on the concentration, initial concentration. Second order reaction, we do not see an dramatic doubled increase. We see an excess of just one. Because of that, it is not going to be called a pseudo product reaction. Next we have with us is the for a reaction A plus 2B, which gives C. Rate is given by KAB. Hence, the order of reaction will be. I just solved it in the previous MCQ. The reaction rate will be K to the power is 1, and B, A to the power is 1, and B to the power is also 1. So if we add 1 plus 1, which was the formula of order of reaction is A plus B का sum. So it's going to be 2, and it's going to be a second order reaction. I hope that these MCQs discussion is quite beneficial for all of you. And we will be discussing the next MCQ, which is a chemical reaction A to B. The rate of reaction doubles when the concentration of A is 4 times. Order of reaction. It means we are saying that that particular rate is decreasing and the concentration is increasing. The rate is decreasing. So it is actually doubled and it is actually 4 times. So because of this particular thing, we say that it is a half order reaction. Why it is a half order reaction and not a second order reaction? Why it is not a second order reaction? Because it is having an inverse relationship. In second order reaction, if a quantity is doubling, the other quantity would also double with it. Okay, so it's going to be a half order reaction. Next we have with us is the what will be the order of reaction if doubling the concentration of reactant increases the rate by a factor of 4. Simple. If we double a reaction, then its subsequent is also going to be double, and the overall answer we'll get is 4. It means the second order reaction is being used. If we triple the concentration, then we'll see a factor of 9. Okay. Next we have with us is that one, the concentration of a reactant in a reaction is increased by 8 times. The rate is increased by 2 times. Well, it's very simple that if we say 2 to the power n is 2 to the power 3. So we are watching over here that the rate is increased only by 2 times. It means the rate is only 2 times, concentration is 8 times, which means 2 to the power 3. If we keep it over here, then we get the answer 1 by 3. The n's value is going to be 1 over 3. Next is that the particular, yes, the rate law of reaction is rate is equals to A to the power square B on doubling the concentration of both A and B. The rate of reaction increases dash times. Well, it's very simple. How it is that we are increasing the rate of both these particular equations. And when we are increasing, 2 is increased, and we see that 2 becomes 4. And we also see that, yes, K is A to the power square and B. So over here, the power of B is 1, the power of A is 2. So we see that if we are doubling the rate is equals to 2 times of A square and 2 times of B square. So we say that 2 to the power 2 is 4 times. And we have 2 times B also. 4 2s are 8. So the rate reaction increases 8 times. Next we have with us is that for the reaction A plus B gives C plus D. Well, let's solve this particular reaction. The concentration of both the reactants increases the reaction rate by 8 times. So the reaction rate is being increased by 8 times, and doubling the initial concentration of on B simply doubles the reaction rate. So we have two things. First, the reaction rate is increasing by 8 times. And then if we only talk about B, which we are doubling, then the reaction rate is doubling the initial concentration of B actually doubles the reaction rate. Let's solve it. Well, if we say that the rate 1 is K A to the power M and B to the power N. Now, we say that B is being doubled. Saw it in the MCQ that it is being doubled. So what is going to be the rate? Second rate is going to be R is equals to K. Now we'll use the big brackets for it. A to the power M, and we have a doubled increase for B. 2B to the power N. So this is the overall situation right now of the MCQ. So we say that over here, if we just keep it aside, this particular condition of A to the power M, B, 2 to the power. Now what happens? See that the rate 2 is the N. If we keep rate 1, we see that rate 1 is stored 2 to the power N. Why? Because we have both over here. And the concentrations are only 1, 1. Initial concentration is 1, 1. So if we just multiply them, like 2 to the power N was actually double at that particular point, and then we have it over 1. So we have the overall reaction as 8. How is it? Let me solve it for you guys. If we see that the third rate is equals to 8 times of rate 1, as we saw in the MCQ. Now what happens with us is this thing. I just did directly. We will make the equation as 2m dot 2 to the power 1. This particular one, which is equals to 8. 8 times R1. Okay. Next we have it, if we solve it, 2 to the power m plus 1 is equals to 8, which will be equal to 2 to the power 3, because we know that n is equals to 2 to the power 3. So we have the value of m, which is equals to 2. So in this particular case, our answer is going to be rate is equals to k to the power a square b. If I just summarize it all for you guys, we did the step 1 as rate 1 is equals to k, a to the power m and b to the power n. Next, we had in the MCQ, which was b is being doubled. So when b is being doubled, we will say that it is 2 times b to the power n. Now we are just concerned with the powers and not with the alphabets. So if we say that 2 to the power n and a to the power m is the equation of rate 2. And we also know that rate 2 is 8 times, according to the MCQ, 8 times of the initial concentration. So we will say 8 times 1. Now, if we keep 8 to the power m, instead of writing 8 to the power m, we use 2. 2 to the power m, which is being multiplied by the initial concentration, which is R1, 2 to the power 1. This is being equals to 8. So m and 1 are going to be added, and then the value of m is going to be deduced. We know 8 is 2 to the power 3. The 3 minus 1 is equals 2 to the power is equals to 2. So the value of this particular MCQ is going to be k to the power a square b, not a option. Next MCQ that we have with us is the change in concentration of reactants of products per unit time is called rate of reaction. The rate of reaction dash. Part 1 is the increases as reaction proceeds. Well, you guys must have seen a graph where we see that when the reaction is proceeding, it is increasing. A time comes when it becomes constant. And then eventually the rate also starts to decrease. Why does that happen? Well, the change in concentration of reactants of products decreases as the reaction proceeds. Why does that happen? Because there is this thing that, as we talked in the collisions, when the molecules have to react with each other, they have to slow down. Their concentrations actually become equal or they decrease, and that particular point, those particular molecules are reacting. So we say that according to the graph, they decrease as reaction proceeds. And by the end of the reaction, finally, it is coming to the below point. Okay. Next we have with us is that with the increase of 10 degrees C temperature, the rate of reaction doubles. How does that happen? This increase in rate of reaction is due to, well, it is due to the decrease in activation energy. No, because of decrease in activation energy, the overall rate decreases. So it's cross. Decrease in number of collision between molecules. No, because if the molecules collision is increasing, the temperature will also increase. Arrhenius equation. Effective collision. Increase in activation energy. No, because of the increase in activation energy, the molecules will start to move not that fast. So we have D as the correct option, which is increase in number of effective collisions. Next we have with us is this particular MCQ, which is the minimum amount of energy required for an effective collision is called activation energy. Perfect. Which one of the following statements is incorrect? Most important word is over here, incorrect about activation energy. Well, if I talk about the A and B options, even if you don't know, I would tell you that these are the exact facts. And they have been shown in the factor collision theory according to Federal Book. There's this whole diagram where we see that how the rate of products is increased and the rate of reactants is increased. And in the latter, we see that the number of reactants are products are increasing and reactants are decreasing. So these are exo and endothermic reactions. So these two are not the answers. Coming on to the next one. EA is directly proportional to K, yani activation energy is directly proportional to K, and activation energy is independent of temperature. Well, activation energy is independent of temperature. Is this incorrect or not? Yes, this statement is actually correct because activation energy, according to Arrhenius equation, is according to Arrhenius, it is correct. Activation energy has a great role in the temperature stuff because without temperature it is. Then we have E is directly proportional to K. No, it is not directly proportional to K. The answer will be C. Next we have with us is that the order of reaction is the number of reacting molecules whose concentration alters as a result of chemical change. For which order of reaction, unit of rate constant is same as that of rate of reaction? Well, in the first order reaction, it is independent of the initial concentration, so it will be cross. Second order reaction, it doubles. Third order reaction, it triples. So we have with us only one option left, which is the zero order reaction. So for zero order reaction is actually showing us that it is same as that of rate of reaction. You see that those reaction of ozone and the reactions that are going on in stratosphere, they are all known as zero order reactions. Next we have with us is our next MCQ, which is that which of the following statements about order of reaction is incorrect? Well, I told you all one thing that I wanted to tell you is that I'll tell you right now. The order of reaction cannot be found by just looking at the MCQ. Okay, it is done experimentally. That's why when the MCQ of hydrolysis of acetate came, at that point I said that you should know from the books. Otherwise, it is done in the laboratories. So from this particular thing, that I think that A option is the correct one. D option, it is determined experimentally. Well, order of reaction experimentally is done, but not that effectively. Okay, so right now, according to your books, B option is incorrect. Next, sorry. Which of the following statements about order of reaction is incorrect? So option A is incorrect. Option B is correct. Option C is it is associated with the rate equation. Yes, because you are talking about rate law at that particular point. And then we have option D, which is it is always equal to molecularity. See, the mechanism of reaction and molecularity, both these things have nothing to do exactly with the order of reaction. Order of reaction is being judged in the laboratories when experiments are done, then rate laws are being applied, and all of that happens. As far as the molecularity is concerned, what is actually molecularity? Any guesses? Well, molecularity is the number of reactant particles which are involved in the most initial steps of the reaction. So molecularity is also not at all related to the order of reaction. So over here, option A and B are correct. Next we have with us is that in which of the following order of reaction half-life is independent of initial concentration. Well, in first order reaction, as I told you, in zero order reaction, it's quite same. In second order reaction, it's doubling, etc. Next, we have with us that all of the following factors affect the rate of reaction, except, well, I've discussed with you all, an MCQ earlier came that the concentration of reactants, catalyst, temperature are the driving force of a rate of reaction. So what left behind is the molecularity, which is just the number of reactant molecule particles and nothing more. So we can't say anything like that about the rate of reaction. Coming on to the 30th MCQ, which is the addition of catalyst to a reaction can change enthalpy, entropy, nature of products, activation energy. Well, the most suitable option over here will be the activation energy because enthalpy, entropy are usually discussed in thermodynamics. And secondly, that enthalpy and entropy are not being controlled by catalyst. Catalyst work is just with the activation energy and nothing more. So we will use this best option, which is activation energy. Coming on to the next one is that the experimental relationship between the rate of reaction and concentration of reactant is called what? Well, it is known as it is a statement of rate law, which is actually describing the relationship between a particular chemical reaction and reactants. So, if I talk about the other options, for example, in paper, God forbid, you just forget what is rate. Come on to the next options. That's how you solve an MCQ. B option is Hess's law. Hess's law is actually the Born-Haber cycle application stuff. It is in thermodynamics, nothing to do with it. Law of mass action deals with reactants and products and nothing more. So we cannot discuss it over here in terms of chemical reaction rates and stuff. Next is Lee Chatelier's principle, which is discussing equilibrium mixture. So it is also not correct. So we have the correct option, which is rate law. Next MCQ is that is very, very important because many of us make a lot of mistakes in this particular MCQ, which is that the specific rate constant is equal to rate of reaction when concentration of reactants are taken as unity. This is the whole definition of specific rate constant. Let's discuss the MCQ. So which of the following factors affect specific rate constant? Keep it in your mind that rate of reaction is being affected by all, but specific rate constant is being affected by just one thing, which is temperature and nothing else. It is not being, if you increase the concentration of reactant space, specific rate constant does not changes with pressure, with surface area, it does not change. So the correct option is temperature. Next is the learning based MCQ and also a bit easy one. We have with us is this MCQ in which it is being asked that which catalyst and what is the behavior of it. Is it which of the following is heterogeneous catalysis? Well, if we see the option number A, we see that 2SO2, O2, and SO3 gas is being formed. We see V2O5 is particularly in solid state. We see that CH3COH, C2H5OH, CH3CO, C2H5, and water. All of this, including the H positive ions, are in aqueous state. So it is a homogeneous catalysis. Talking about SO2, O2, NO, and SO3, they all are in gaseous state. So they are also homogeneous. So the correct option is going to be alpha option. Why? Because SO2, O2, and SO3 are gases and B2O5 is solid. Next one is the calculation based MCQ. It is an easy one. Usually for calculations, the advice is just this, that all of you should not use the calculator at all. Why? Because in paper, it would help you in just doing the quick calculations. In this particular MCQ, we see that the rate of reaction is doubled for every 10 degrees. The increase in reaction rate as a result of temperature rises from 10 degrees C to 100 degrees C. So we have the change in temperature which is equals to 90 degrees C. If we say that if we keep that 90 degrees C and we divide it by the every 10 degrees C rise, we divide it by 90 divided by 10, we see 9, which is 9 steps actually. So we have the value of n. For finding the value of n, we did this particular what we say step. So we have 9 steps as the value. Now 2 to the power n, putting it into the formula, 2 to the power 9, which is equals to 512. And 512 is going to be the correct option. Next is rusting of iron is an example of. Well, all natural processes are so slow processes. Like we see the ripening of fruits is also a slow process. So all natural processes are slow process, artificial processes are faster processes. Next one we have is that reaction kinetics is concerned with. So this is such an easy MCQ, but you have to read almost all the options and then mark the answer. Reaction kinetics is concerned with rate of reaction, direction of reaction, factors affecting both A and C. The correct option is going to be A and C and not B. Why not B? Because in this particular reaction kinetics, we are talking about how a particular reaction is working, but not the direction of reaction. It is direction of reaction is being talked in chemical equilibrium chapter, in which we talk about the dynamic equilibrium and all those things. Okay. Next we have is the activated complex is a substance, which is, well, I told you all that it is a transition state in effective collisions. And we say that it is one of the unstable. It is in this form as shown in the federal book. And it is the transition state. It is the activated complex, whatever you want to call it, or your book is calling, and it is very unstable and it is for a very short time. So we call it a unstable state. Next we have is the reaction is first order with respect to A. It means we'll write it as with respect to A, it is first order reaction. And second order with respect to B, it means B is going to be 2. So the rate equation is, as we saw, alpha is the rate equation. Next we have with us is that for reaction A product, doubling the concentration of A quadruples the rate. It means that the rate is second order reaction. 2 to the power 2, it's becoming 4. It quadruples the rate. Next one we have with us is that it's a out of course MCQ, but it is very important in terms of that if you get bars or something like that, or Pascals, all these things in your paper. So the MCQ is that consider gas is measured in bars, then the unit of rate reaction is. Well, it's going to be not, but what is actually the equation? Mole per dmq per second. This is actually the reaction. So how do we write it? We write it in terms of bars. So if we say that 1 mole per dmq is equals to 1 bar, so 1 bar is going to be written as 1 bar per second. That's how you deal with this kind of MCQs, simple calculation. Next one we have with us is the English portion. I hope that you guys understood reaction kinetics. There were 2-3 tricky MCQs, but I think that if you go into the PreMed topicals portion and do them again and again, it's going to be really beneficial. We have with us is that each of these substances dash in Pakistan. MCQ 1 of English. While each is plural, and with plural, the combination goes is that each is showing her ek substance. So for that, we will use is found. Okay. So the answer is not going to be each of these substances are. It is incorrect. Each of these substances is. Next we have is the sentence correction form. We'll start reading from number one. Young needs to be encouraged and supported in society. Well, before young, there should be some kind of article to make it a sensible sentence, so it's incorrect. Next, we have is a young need to be encouraged and supported in society. A young with young is a group. It is showing us over here that it is a group, so it is incorrect as with groups we don't use article a. Next is the young needs to be encouraged and supported in society. The is correct. But over here, it is needs. S is not being used when we are talking about groups. So the correct option will be the young need to be encouraged and supported in society. Next one is that startled onlookers saw officers armed themselves and took up positions in front of the house. While startled onlookers saw officers armed themselves. The first part of the sentence seems to be correct. Next is and took up positions in front of the house. This phrasal verb took and up. First of all, up over here is incorrect and took is going to be only correct one. So it will be and took positions in front of the house. Next we have with us is the MCQ. You think it's a practical joke? She asked as they went into the room. See, you think it's a practical joke. It is a question, it is giving a sense of a question, not a sense of a sentence. So the first part is going to be correct one. You think that it's a particular joke is going to be with a question mark, and then it's going to be correct. Next is capacious. Capacious synonym is ample. Capacious mean a wide space. We have cramped, which is its antonym, which is less space. We have stagnant smell. Stagnant is about rivers or something which is not working. Then is dormant conditions, which is that inactive conditions. We use it for that. Next one we have is this: consider the given statement to be true. And we have to see that if these statements are true or not. We have the statement as Pakistan is a multilingual country. Urdu is national language of Pakistan. So conclusions are, all Pakistanis should learn many languages. To be a Pakistani, one needs to learn Urdu. See, option 1 and option 2. Both of these are considered as opinions and not the facts, not facts. So over here, we have to answer it with true or false. So both these options are marked as incorrect, and they are not kind of showing us the correct answer. Okay. Next one we have with us is this particular series of numbers. If you see that, what is the difference between 108 and 75? Simply, the difference between 108 and 75, just simply minus it. 108 and 75. It's going to be 33. If you find the difference between 48 and 75, what is the difference between this? 48 and 75. We have 48 and 75. 15 minus 8, 1, 2, 3, 4, 5, 6, 7. 7. 6 में से 4 निकाला 27. We have the differences like that. So अगर आप इस तरह माइनस करते जाओ, 12 में से 3 निकालो 9 आता है, 27 में से 12 निकालो तो we get something like 27 minus 12 कितना होता है? 27 और 12, 7 is to 5 and 15. We have a difference of 15. So what is going to be the answer? The difference between all these terms is almost up to, like, we have 9, then we have the difference between 12 and 27 is 15. We have the difference between 48 minus 27, 1 and 21. We have the difference of 21. Then we have the difference between 48 and 75, which is the difference that I just calculated, 27. And we have the difference of 75, 108, which is 33. So from this, we see that this is all giving us the difference between 15 and 19. We have a 6 difference, 15 and 21, 6 difference, 27 and 21, 6 difference, 27 and 33, 6 difference. So 33 plus 9 is 39. So the next term we are going to have is going to be 147. 108 plus 39 is 147. Next one is an easier one, and let's just make a good equation of it and answer this particular one. Each problem consists of 3 statements. Tanya is older than Eric, and Eric is older than Cliff. So Eric is older, no, Cliff is, Cliff is actually older than Tanya. Okay, so the question here is Eric is older than Cliff. They are saying that if 2 options from the above are correct, then please tell that if the third option is correct or not. Third option is correct or not. If we see it that Tanya is older than Eric, Tanya is older than Eric, and Cliff is older than Tanya, it means that eventually Cliff is also older than Tanya. This happens in the equation, so this particular state is false. Next one is that the State Bank of Pakistan has recently put restrictions on few small banks in the country. The small banks in the private and corporate sector in Pakistan are not in position to withstand the competitions of bigger banks in public sector. Well, the statement 1 is showing us that there's been a recent upheaval, and then we are watching that the statement 2 is showing that the small banks are not doing well. So we will say that statement 1 has been the cause which is leading to the effect that the small banks are being closed. If you do this thing like that, that the small banks in the private and corporate sector in Pakistan are not in a position to withstand the competitions of bigger banks in public sector. So if you do the conjunction, so the State Bank of Pakistan has recently put restrictions on few small banks in the country. In this way, the particular thing of cause and effect is going to be clear to all of you. Now we have our next and last MCQ, which is severe drought is reported to have been set in several parts of the country. What is a drought? Drought is कहत. Government should immediately make arrangements for providing financial assistance to those affected, and food, water, and food should immediately be sent to all these areas to save the people and cattle. Well, according to the first one, at this particular stage, the thing of financial assistance is not that required. And the thing that is required is actually food, water, and these things. So second option is the correct one. I hope that you like the lecture, and this is all for the reaction kinetics. Keep solving the MCQs, do go through the topicals and understand it all. And in this way, that this whole lecture is going to be easier for you. And in this way, the MCQ attempt, you would understand it. So thank you so much. That's all from my side.